Good morning. We will be simulating a simple circuit involving an ideal operational amplifier. This is the circuit that we will be simulating today. So the input, which is 1.5 volts, is connected to the inverting input of the amplifier. Therefore, this circuit is an inverting amplifier. For an inverting amplifier, the gain is given by negative RF over R1, where RF is our feedback resistor and R1 is the input resistance, which is 20 kilo ohms in this circuit. By calculating using the formula, the expected output is negative 250 kilo ohms over 20 kilo ohms times 1.5 volts. The result is expected to be negative 18.75 volts. Now we will simulate this in Multisim. Control W for the shortcut. We need this component OpAmp 3T virtual. So make sure that the group is in all groups as you search for the component of the OpAmp 3T virtual. Click OK. Then place the component. And then we need Control W again. We need the DC supply. It's not VDC. DC power. Yeah, it's DC power. Also notice that at the top must be the inverting, so we'll try to right click and then flip vertically so that the signs will change. Now negative, the inverting input is at the top. Control W, let's add the ground component. So for the positive, we need two resistors. Control W, resistor rated, another resistor. Then let's connect the components. Then change the values. 1.5 volts for the input. Right click, double click, and then change the value 20k. The other one is 250k. And then double click this wire, we'll label it V out, then click show net name. Okay, so we now have the circuit. All we need now to do is to simulate analysis and simulation. Again, from the simulate toolbar, we will click analysis and simulation, and then we'll just do simple DC operating point simulation because we just want to find out the value of V out. Click V out and then add. So V out is now added to the variables for analysis. Click save, then we'll click run. The output V out is negative 12 volts. Our expected value is negative 18. We need to increase we need to do something with the OpAmp characteristics. Oh, what has happened? Our expected value is 18. The characteristic of an OpAmp is whatever the voltage swing 12, for example here, the voltage swing positive and negative is set to 12 volts. The output cannot be greater than the supply voltage. That's why when we simulated, the output is only at negative 12 volts. Our expected value is 18. Our supply voltage must be greater than or equal to 18. We will set the voltage swing to 30 volts, 30 and negative 30. Click OK. And the output is at negative 18 volts, which is negative 18.4874. Negative 18.74, which is closer, very much closer to our calculated value of negative 18.75. So that's how we simulate. This is called DC operating point analysis. That's how we simulate in Multisim to determine the DC output voltage. As simple as that, using an ideal OpAmp. That's it. Thank you for watching. Please subscribe to my channel. Thank you.